Okay, today's lesson is 55 nets. What's our objective, class? Get ready?
Nets.
Nets. You will learn how to recognize, draw, and label nets of prisms, pyramids, cones, and cylinders. 1, 2, 3, eyes on me.
1, 2, eyes on you.
Thank you. Now I know you're listening because you're sitting up straight, you're in slant position, you're making eye contact, so thank you for your attention. Okay, so if we took a net, or if we took a three-dimensional picture like a pyramid, and sliced it along some of its edges and laid it out flat, and we would end up with a drawing like this. It's called a net. What is it called? Get ready?
Yes.
A net. You can actually cut them apart in different ways. So I'm going to show you. Here is another pyramid. Okay. It's got a square base. That's important. Think about the number of sides. It's got 4 sides. 1, 2, 3, 4. 4 faces and a square base. Well, this net is going to come out a little different because they sliced it along the base. So this got sliced there, there, and there. So it's a different way to draw a net. So think a little bit creatively when you draw these. It doesn't have to be one way. In fact, here are several more ways of the same exact thing. So just picture just reorganizing some of these triangles. Maybe this triangle was connected down here, right? Or down on this side. And so you could slice them up in different pieces. So we're going to look at a bunch more like that. Okay, here is a net of a shape. What shape do you think it would make if we reconstructed it? What do you think, Tate?
Cylinder.
It's a cylinder. So, let's get this out. All right. So here's our 2 circles, right? That part's obvious. There's a base step, but the part that's not so obvious to everybody is it's a perfect rectangle. Now look at this. This circle right here has a circumference or a perimeter around it, and this length of the rectangle matches exactly to that circumference around the circle. So could I say that the length of my rectangle is the same length as the perimeter of the circle?
Yes.
Which I know to be 2 pi r, right? Pi times diameter or 2 times pi times radius. So if I took this length and said, hey, that's going to wrap around, so I know that's the circumference. The length is 2 pi r, which is the same as this one, right? This would also be 2 pi r around the outside. And then take my cylinder, look how tall it is. It could have a height, right? So from here to here is the height. Well, isn't that the distance from here to here? So if I turned it this way, is this my height of my cylinder? So I can call that height of a cylinder. So I'm going to write down a name we're talking. Make sure when during construction that there was no talking. So we've got area equals 2 pi r times h. What is my area, class? Get ready?
2 pi r times h.
Yeah, 2 pi r times h. And our 2 circles, we already know to be pi r squared and pi r squared. And look, if I were to do the full surface area, here's my 2 pi r h, the inside rectangle. And there's 2 circles, pi r squared and another pi r squared. So 2 pi r squared. So I could do surface area by breaking it down into shapes that I know and figure out surface area. So that's something more advanced than some of you got last year. Take out your whiteboards. We're going to sketch a net of this triangular prism. You're going to come up with your own creative way to draw. Now look at it. What is it made of? It's got a rectangle here, a rectangle there, a rectangle on the bottom, and 2 triangles. How does your brain see them connected? Draw it on your whiteboard and hold it up. Oh, Bethany did a great drawing, very fast. Yes, Josh. Stacia looks good. There's a very creative way. Oh. I'm gonna add on to yours. You did a triangle at the top, right? Okay. So Alex did his a little bit different. He took the base, he opened up the 2 triangles and says, you know what, I'm going to take these other 2 flaps and I'm going to connect them somewhere else. Don't they connect onto one of the triangle edges? I'm just going to modify yours slightly because they actually connect down at a right angle. So I just did you see that? Yeah. And so this would come off too. Right there. What's important in your drawings? Very good. Yes, I like the dotted lines, and that works too, Spencer. Hold your boards and show each other, so you see some of each other's drawings. They look good. Okay, go ahead and set them down. Looks very good. I like that one too. Okay, 1, 2, 3, eyes on me.
1, 2, eyes on me.
drawings is to know the pieces that are going to touch each other when you reconstruct your three-dimensional object. This piece and this piece, they're going to fold together and touch each other, right? So I really should draw them the same length. Same thing here. You know, I don't know how exact I made it, but that side's going to come up and touch this side, so I should try to draw them about the same length. So that's important. The next one we're going to do, not only is the drawing important, but the labeling is important. So we're going to label the sides according to the dimensions given. So the front is my biggest face. It's a 4 by 3, right? So we're going to draw the big front. 4 by 3. But the side of it, it's only a 2, so it's really half the length. So I want to show that in my drawing. I want to show half the length about. That's the same height. So it's a 2 by 3. Then the back of it's going to match the front. So it's, again, twice as long. 4 by 3. And then I have another side, again, a skinnier side, matching the other side. And they're all 3s in height, but I don't have my top flap or my bottom. So I'm going to add those on. So, I mean, I couldn't I add it on up here? But that would be weird. We don't really, like if you're thinking of a package like of cereal, we wouldn't open a flap like that. But we could. It's usually like this. But how big is it? Well, what's my dimension here? It's a 2, and I know the flap has to fold over onto that spot. So it should be about the same height. So this is 4 across and 2 wide. See how the 2 is going to fold over like that? So they have to be the same. Then I have another flap. So it's important, again, make sure those 2s and 2s are about the same length. They're going to fold over. Now, what if I took a different shape? I'm going to erase this. This is the one that comes up in the practice set, and students struggle on it a little bit. Okay, what if it was like a block of cheese? All right, and let's suppose I gave it 4, 5, this would also be a 4. And then this is a 3, and this is a 4. Actually, I'm going to make it different. I'm going to make a 6 and a 6. Okay. Could you draw the inside so you can see, oh, what's really going on in here? I've got a base. It's 6 by 3. I've got a back. It's 6 by 4. I have a top. It's 6 by 5. So you think, okay, I have 3 rectangles. 6 by 3, yes, you can. A 6 by 4 and a 6 by 5. So as you draw that out, you need to consider 6 by 5, 6 by 4, and 6 by 3. And you're going to label each of those appropriately. Then you're going to pick, where do I want my triangles to go? I don't want to give it away because this is in your practice set, but I just want you to think three-dimensionally, all right, and flatten that out. Okay, multiple choice question. Which is the correct net of a cone? If you were to slice it and unwrap it, and flatten it out, what would it look like? Let's take a vote. If you think it's figure 1, raise your hand. If you think it's figure 2, raise your hand. If you think it's figure 3, raise your hand. Okay, the 3s are right. Let's look at it for real. We have one. We have a cone. This is one that is kind of weird because it's flat on the bottom. So you would think if I unpeel it, it's just going to be like straight across. The apex is what makes it not. It all has to converge up to the middle, so look at that. It doesn't open straight across. It has a curve to it. And this side opens as well. So it's like an angel for Christmas. Okay? And then you've got, so here's, see our curved side, and this one doesn't open up as much as it probably should. But the point is that this curve, that's what lets it wrap around to the bottom and still converge up to the apex at the top. Look at this formula. Okay. If they said, hey, pi r L plus pi r squared, well, we haven't learned anything of this, but we have learned that the area of a circle is pi r squared. So I could assume pi r L would be the area of this remaining part. And this is one you don't have to memorize, but to look at the formula, you could, by reasonable deduction, assume this part is the area of this section of the cone. Yes, Lucas?
Couldn't you figure that out because you would be able to measure how long the radius is of the top part?
Mm-hmm.
And then you can just say, okay, now a fourth of that, so you need to find the area of the entire circle and a fourth of it.
This looks like a fourth. I thought the same thing. That's not a fourth. Yeah, but good observation. Don't trust that it looks like a fourth of a circle. And they didn't even tell us what L is on here, but I'm assuming L is going to be the slant length right here. So how slant versus the height of it. The height would be how tall the cone is, you know, from here to the bottom. That's not even taken into account. But L is probably the slant height, which we don't even use this formula, or the slant length. Okay, it's for today. You have B, C, and D. On D, you need to give me a net with everything labeled.